Hello everyone, my name is Ahmad Khan and I'm a Year 3 Mechanical Engineering student from Ahmad University, Malaysia. And today I'm here to talk about the magnificent engineering of an airplane. Now, isn't it mind-blowing that an airplane which weighs around 80,000 kgs is just controlled by only two pilots? Well, I wouldn't give full credit to the pilots, but to the engineers who actually designed this beautiful piece of engineering. Now, here's a picture of a Boeing 747. Now, when you first look at an airplane, you can notice that it has engine, wings, tail wing, tires, etc. But now, let's have a closer look at the wings of an airplane. Now, if you look closely, you can notice that the wings are not just made by one single piece, but in fact, they're attached by some movable parts, which play a major role in the engineering of an airplane. Now, as you can see from the diagram, the highlighted areas are the movable parts of the wing. Now, let me tell you an interesting fact. The wings of an airplane, they form a very special shape in fluid mechanics, that is the airfoil. Now, let me blow your mind. It has been said that if you understand the physics behind this simple shape, this will allow you to understand the physics behind the entire airplane. Wow, isn't that amazing? Now you might be thinking that what makes this simple shape so significant? Now, in order to answer your question, let's look at the aerodynamics of an airfoil. Now, as you can see from the diagram, when the airfoil is moved with relative to air, it produces a lift force, and then this lift force is used to lift the aircraft. Now, let's look at a more practical example for a better understanding. Now, let's just suppose that the airfoil is moving at a certain speed and it is moved across air. Now, when it is moved across the air, it produces a downwash, and then this downwash further creates a pressure difference between the top and the bottom of the airfoil, which looks something like this. You have low pressure at the top and high pressure at the bottom. Now, due to this pressure difference, there is a force exerted, and then this force is called the lift force. Now, let's talk about ways to increase the lift force. At number one, we have higher angle. So higher the angle of the airfoil, higher is the lift force. At number two, we have higher speed. Now, you might have noticed that the runway for an airplane are pretty long. This is because the pilot has to make sure that the airplane reaches maximum speed before taking off in order to receive high lift force. Hence, higher speed equals higher lift force. Now the last one is the flaps and the slats. Now remember when I was talking about the movable parts of the wings? Well, flaps and slats are nothing but two of the movable parts of the wing. Now, how do flaps and slats help in increasing lift force? Now, before taking off, what the pilot does is it alters the shape of an airfoil. Now, as you can see from diagram number 1, the position of the slat and the flap are at the original position, but at the second diagram, their position has been altered. And because of this alteration, there is an increase in wing area, and because of wing area, the airfoil becomes more steep, and because of it being more steep, there is more downwash created, and because of more downwash, there is a higher pressure difference, and due to higher pressure difference, there is more lift force. Wow, isn't it great that just a simple alteration in shape can give you so much of lift force? Well, apart from the slat and the flap, there is another movable part in the wing, which is called the ailerons. Well, the aileron is functioned in such a way that it can move up and down. So as you can see from diagram number 1, when it is moved up, it provides a lift force which is required when the plane is about to land. And the second diagram, the aileron is moved down. in which it provides high lift, which is required when the plane is taking off. Now, let's talk about the tail wing of an airplane. Now, there are three movable parts in the tail wing. We have one rudder and two elevators. Now, the rudder is responsible for all the horizontal forces experienced by the airplane, whereas the elevators are responsible for all the vertical forces experienced by the airplane. Now let's move on to my favorite part of the video, the takeoff. Now slight reverse gear. Now remember when I was talking about ways to increase the lift force? Well, while taking off, the pilot makes sure that he follows all three steps in order to gain maximum lift force so that the takeoff is done smoothly. Now, as you can see from the screen, I have three diagrams here of a plane taking off, and we'll go through them one by one and see what process goes through. So, as you can see from diagram number one, the plane is on a runway and it's ready to take off. So what the first step, what the pilot does is to attain speed, and to attain speed, it uses the engines, and the engines provide thrust, and the thrust gives speed. Now, once the airplane is at a maximum speed, what the pilot does is it alters the shape of an airfoil using the flaps and the slats, as you can see from diagram number 2. Now the last step, what the pilot does is, using the elevators, it elevates the airplane at a certain angle, which gives a higher angle for the airfoil, and maximum lift force is being given out, and this makes sure that the pilot gains maximum lift force and the takeoff is done smoothly. Now, in all this process, we talked about the thrust provided by the engine. Now, how does the engine manage to do that? So, in modern airplanes, they use a specific kind of engine called the turbofan engine. Now, in a turbofan engine, the fan's reaction and the reaction force of the exhaust is responsible for giving out thrust. So more the fuel burned by the pilot, more the speed it attains. Now, the interesting fact is that the fuel tank of the airplane is located at the wings of an airplane. So as you can see from the diagram here, these are the locations where the fuel tank is located. Now the plane has taken off. So the next stage for the airplane is the climbing. So in order for the airplane to climb, there are certain conditions. And the condition is that the thrust provided by the engine should be greater than the drag force. So if this condition is maintained, then we can say that the airplane is continuously gaining speed and is climbing. Now, once the climbing is done, it reaches the level flight. Now, once the airplane has reached the level flight, now the conditions have changed. Now the drag force is equal to the thrust provided by the engine, and the weight of the aircraft is equal to the lift force experienced by the wing. Now let's talk about one of the most important phenomena in the airplane, that is changing direction. Now most people assume that only the rudder is responsible for changing direction, but actually there's a lot more into it. But let's just suppose that if the rudder was responsible for the changing direction, then this direct change would damage the aircraft and cause a lot of discomfort to the passengers. So what the pilot does is it uses the concept of centrifugal force. Yes, you heard me right. Centrifugal force. The pilot uses centrifugal force for a smooth turn and without causing any discomfort to the passengers. Now I have 4 diagrams here, as you can see on the screen, and I'll be explaining one by one on how the pilot manages to change direction smoothly. So while it's time to change direction, what the pilot does is it alters the position of the ailerons. So the left side of the aileron goes down and the right side goes up, or maybe vice versa, depending on which direction the pilot is turning. So because of this, there is a shift in balance of lift. So at one wing, there is high lift and the other there is low. So because of this, the airplane is rotated in a certain manner. And when it is rotated, the vertical component of the airplane now gives out centrifugal force. And because of this, there's a smooth change in direction of the airplane. It's so amazing to think that simple physics is applied to huge objects like airplanes to perform big tasks. So now let's move on to the landing of the airplane. So as you can see from the diagram, the during landing, the nose of the aircraft is faced downwards, which is completely opposite in the case of landing. Now, while landing, the pilot again alters the shape of an airfoil using the flaps and the slats. Uh, because of this, now the plane is at a lower angle, so there's a lower angle at the airfoil as well. So because of this, there is an increase in drag force, which makes sure that the plane is slowing down. Now, once the plane has landed and is on a runway, it is at a very high speed. Now, there's another movable attachment in the wing called the spoilers. Now, the spoilers are activated. Now, what these spoilers do is it further increases the drag force, which helps the plane to stop. Now, one last step, what the pilot does is it is called the reverse thrust. So what happens here is the pilot opens the cover of the engines. So now the air which was going back is now forced forward, so which further increases the drag force, like as you can see from the diagram here. Now, doing this, the pilot makes sure that the plane is stopped from a very high speed, and that's how the plane is landed. Now, it's so we definitely can't deny the fact that that an airplane is surely a beautiful piece of engineering, and it's so fascinating to think that the airplanes have evolved so much over the years. But this also makes me wonder that what do the engineers have for us in the near future? So with that being said, let's talk about what can we expect in the near future. So as most of you might know that every means of transport around us is getting electrified. Well, airplanes are no exception. So a little off topic, but did you guys know that an airplane consumes around 150,000 liters of fuel in a course of 10-hour journey? Well, that's a lot of fuel, and also it's not so good for the environment. Well, keeping this in mind, what least we can expect in the near future is electric or hybrid electric airplanes. Now, with that being said, let me introduce you to this bad boy, the Airbus E-Fan X. It is the world's first ever complex hybrid electric airplane, which has the main goal of decarbonizing the skies. So how it works is one of the four jet engines is replaced by a 2 megawatt electric motor, and after performing several tests, the company says that it's truly a game changer in the aviation industry, and it also follows the ambition of decarbonizing the sky. Well, apart from the E-Fan X, the Airbus company is also working on their first ever hydrogen powered airplane called the Airbus Zero E. Now, you might be thinking, what on earth is a hydrogen powered airplane? So, by basic understanding, it is how it works is when liquid hydrogen is burnt with oxygen in a gas turbine, it creates a highly efficient propulsion system, resulting emissions of hydrogen dioxide, which is commonly known as water. And water, by nature, of course, is a non-pollutant. So the Airbus Zero E comes up with three concepts, as you can see from the diagram here. The first one is called the turbofan, which is nothing different from a modern day looking airplane, but it is powered by two hydrogen hybrid turbofan engines which provides the thrust. Now the second concept is the turboprop. Uh, so the turboprop is powered by two hydrogen hybrid turboprop engines with, which drives the eight blades, or you can say propellers, which gives the thrust. And the last concept is the blended wing blade, which is by far the most interesting looking concept. So as you can see from the diagram, it has exceptionally wide area, which opens a lot of possibilities of storing hydrogen. And similar to concept number one, it is also powered by two hydrogen hybrid turbofan engines, which provides the thrust. Now, the Airbus says that these concepts can be brought into action by the year 2035. So the other day I was surfing through the internet and I found a very interesting article which said that NASA develops unique materials for next generation of aircraft. So well, that immediately got my attention, and when I looked into the article, I learned that the NASA engineers are constantly working on the betterment of the aviation industry. So recently, NASA engineers have discovered or developed a new material which can be used to manufacture better parts for engine and related systems. So this material is called the silicon carbon fiber ceramic matrix composites. It's a huge name, but this fiber is known for its lightweight and reusable qualities, which is ideal for high performance machinery like an aircraft itself. And this material can operate for extended period of time in punishing conditions as well. So this material can withstand around 2700 Fahrenheit and are strong enough to last for months or even years between their maintenance cycle. Well, after looking into all this, I feel that the future of airplanes is pretty bright, and there's a lot we can expect in the near future from the aviation industry. With that being said, here comes the end of my presentation. Thank you for paying attention, and I really hope this presentation was informative to you all. And yeah, thanks again.